how long would it take a random project to do what we're doing right now?
A long, long time. We have built this from scratch. You know what I mean? Like I've been working on for well over a decade. You mean 15 years?
Right. Not only that from a time perspective, but also from a cost perspective. You would have to have a lot of resources at your disposal in order to actually build what we have in current day. And in the future, as we onboard more of operators, MPC operators, it's going to become even more difficult and costly.
As far as I know, we're the only people doing this, a threshold signature scheme. I mean, that's truly multi-party computation. I mean, other people are saying they're doing this, but we all know they're really not. As far as I know, we're generally the only people that actually do this at scale in an enterprise setting. All the bells and whistles that are required to give you confidence, I mean, in our solution. And we have the experience of running this for years. You mean for like what 5-6 years, and the team has the experience of running this for years. You mean so we know how to do this. We know how to do MPC at scale securely.
Hey Adi, hey Kealan. We decided to do this special webinar to really dive deeper into the MPC specifically, which is kind of the underlying security for everything that we do across all of our DCTs and zenBTC. So, to dive deep into this, we brought on Kealan McCusker, who is our chief cryptographer and really one of the foremost experts in the world on MPC technology. So, Kealan, how are you doing today?
Thanks, Jack. Happy to be here. And Adi, good to see you.
Great. So maybe a good place to start, Kealan, would be to talk a little bit about your background and how you got into cryptography, all the kind of incredible things that you've done in the past to get you to this point.
Yeah, so I started as an electronic engineer in about 97, mostly working in consumer electronics with like Seagate, ST Microelectronics, and then laterally went to some private contracting for Texas Instruments, mostly in ARM-based systems, and I was really interested in error correction codes, and it wasn't a very big jump from error correction coding codes to cryptography. So after about 6 years of that or so, I went back to do a PhD and did a PhD in the area of identity-based encryption, and I finished that about 2007. Then I went did postdoc and worked in the university, and also worked for the National Digital Research Centre, which is a government agency in Ireland. And most of my work was around the commercialization of, first off, my research and then other people's research. And I did that until 2012, when then I joined a company that was working actually in the area that I did my PhD in, and a company called Miracle, with a lot of the people who were involved in the previous company here's Credo as well. So I did that for a few years, and then about 2018, I moved to late 2018, start 2019. I moved to a company called Credo that were doing basically MPC. We're doing securing digital assets. And I worked there for quite a few years, and then recently I've moved to Zenrock about a year and a half ago, and continuing my work in MPC. So what we're doing is we're taking the research papers in the area, and we're basically commercializing them. We're writing everything from scratch, the C code and the high layers, and rolling out a service. And we had a service working in Credo for many years, which was securing, I'm not sure what the figures are, but it was like probably hundreds of millions of assets in a distributed system across the world. And we're doing the same in Credo, but this time we're doing it like in a threshold signature scheme. So that's just a high level of what we're doing here.
So yeah, that's super helpful. It must be really interesting seeing the research kind of come to life in a more commercial setting, which is kind of what I guess you've been pursuing the last 7 or so years, however many it's been. But I think just taking a step back, right? Everyone in crypto is familiar with multisigs. And so MPC, a lot of people will be like, oh yeah, that's pretty much a multisig. And obviously we know it's, a fundamentally superior technology, MPC, right? And so I guess maybe just the first thing that would be helpful is just to break down like what is MPC, and why is it kind of a fundamentally more sophisticated and better technology than like the traditional multi-sig that underpins so much of DeFi?
Well, I'll just explain what MPC is first, specifically a threshold signature scheme. Say there's like 8 people and they want to be part of the MPC network. Each of those 8 individuals will in a trustless manner generate a key share of, say, ECDSA, and they will then give that key share to everybody else in the network. Everybody does the same thing, such that when we add all those shares together, it's like a Shamir secret sharing of the full key, but no one person ever sees the full key. So the key is never ever reassembled. Nobody ever sees it, and then we can use those key shares in a threshold setting. Say this threshold is 3. 3 of those MPC nodes could come together, not literally, but they could agree that we're going to perform a signature, form a signature, and they go through a protocol, and they get a signature share that they then send to each other, and they can all sum them together, and that's a valid signature. So that's how MPC works. So it's basically, it's off-chain. An ECDSA signature generated that will work anywhere that supports ECDSA. Whereas, so it's blockchain agnostic, whereas multisig is not blockchain agnostic. It's every blockchain had its own multisig, right? In addition to that, there's also the privacy benefits if that's important to you. You don't know how many people have signed. You don't know how many people are in the network, and it's never showed up on the chain. It just looks like here's an ECDSA signature, or here's an EDDSA signature. So that there is the privacy benefits as well. And there's also security benefits, because no one user ever holds a private key. A legitimate private key. Whereas multisig, they do. If you lose a private key in multisig, that is a real private key. Whereas it will never happen to us, but if you were to lose a key shard, it's just one of many key shards, and we can rotate that. Which comes to the next point of the benefits of MPC, in my view, is its flexibility. We can change the threshold. It could be like 3 out of 8 today, it could be 5 out of 8 tomorrow. We can change the participants, and we can also rotate the key shares, by keeping the same Bitcoin address.
Right.
You could do the same on multisig, right?
Right.
But it's a lot harder. You have to put another contract onto the chain, and cost. And that's another thing to come to as well. I believe the cost of this would be significantly less than multisig. If you just have one signature on the chain, whereas in multisig, you have many signatures, and the on-chain costs are greater. So that's the significant benefits.
Yeah.
Of MPC. Unless maybe I've missed something, but that's how we see it.
I think that's super helpful, and I think outlining the benefits for MPC is very important. But maybe it would be helpful to kind of deep dive into our specific architecture at Zenrock and what we use as a best practice within security, using obviously AWS, Nitro enclaves to secure secrets. Could you go into that a little bit more?
Yeah, in Credo and in Zenrock, we decided to use a secure enclave called AWS Nitro. So we run our protocol inside the secure enclave. Our engineers, me, anybody, you can't see inside the secure enclave. You can't see what's happening inside. There's no logs. There's no way of getting to the key at rest. Even the shard. Obviously, with one shard you can't do anything. But we go to another level, and we say, we don't want anybody even to getting the shard. And so we could actually roll this out to our partners as well. If they're on AWS, and we would provide them basically a shrink wrap solution so they can run our code inside a Nitro enclave as well. So so on their side as well, it's locked down, and nobody's unable to get to any data at rest. I think that's important for people.
Definitely.
Yeah. So it's really interesting. I mean, there's so many advantages of it, and it's kind of just, I think, notable to just kind of very simply lay them out. I think, the whole logic of a multisig, right, is this idea of, okay, well, if we have 8 people that we trust and we do like a 3 of 8, for example, on a multisig, it's like, well, even if one of these people get hit by a bus and lose their key, it's not going to fundamentally limit the system. And since you need 3 of them to come together, it makes the kind of threshold for collusion a lot higher, right? But it's still obviously human beings holding private keys that can come together and do all sorts of things. And I know one thing that's really interesting about our system is that even when you have multiple, you have a similar 3 of 8, let's say, just to keep the numbers the same, which is kind of the initial launch architecture that we're going for. It's not like those that any 3 people can decide, hey, we're going to come together, right? Because there's a random selection process, and there's also this jailing process that I think is really interesting to discuss, which adds just an additional layer of security on what we're doing and makes any potential vulnerability exponentially more challenging than it would be with a traditional multisig. So maybe you just dive into kind of all those points and discuss how that works.
Well, like our system is the MPC sits. You can do MPC without using a blockchain. But what we have done is we've integrated MPC with the ZR chain. So the ZR chain is what triggers the MPC nodes. Each MPC node that we give that a third party runs is connected to the ZR chain and will only start a process for key generation or for signing if consensus is reached on the blockchain. So the blockchain in our scenario is the source of truth of our system. I think that's what you're getting at, Jack. Yeah.
Yeah, exactly.
Yeah, that's how it works. So we're combining MPC and the ZR chain into one system.
Right. And can you speak a little bit about like the key rotation and kind of the random selection of parties coming together to generate any keys? I think that's really interesting as well.
Yeah. So initially, like say with 8 nodes, what we do is all 8 of those nodes, or whoever, we go through a key discovery process or a node discovery process. We check to see which of the MPC nodes are available for key generation, and they should all be available, say it's 8 in this case. And then each one of those 8 will then get some key material that all interact with each other, and they will get a share of the overall key. Then when it comes to signing, we only need 3 nodes. So we'll see which nodes are available. Again, it should be 8, and then we will randomly select 3 of those nodes to perform the signing. And then they will then get the signature and write it back into the blockchain.
Right.
So as it relates to other MPC solutions that custody institutional assets, institutional cryptocurrencies, usually their threshold signature scheme is 2 of 2. But in Zenrock's implementation, it's 3 of 8 for the reasons that you outlined in terms of decentralization and also in terms of mitigating any single point of failure. And this, I think the final piece is very impressive, is the aspect of rotating those keys periodically in order to ensure that there are no bad actors. But what if, let's say, in the worst case scenario, there is a bad actor? What would happen?
Yeah, we're in the C code at the moment, we've got what's called identifiable aborts. We just run that out into our system eventually. So if, say, one node is acting maliciously, we can detect that at the protocol level, and then we can exclude that from that node from future runs of the protocol until such time as we believe they're acting well again, or maybe it's we add in somebody else. And we can actually we can actually exclude that we can rotate the key. We can rotate the actual key that's stored for MPC, the ECDSA key shards, to exclude that bad actor as well. So they're completely out of the network.
Right.
So,
and that's also very important because within Zenrock's MPC, we can host multiple key signatures in terms of EDDSA and ECDSA. Is that correct?
Yeah. So with those two primitives, we support, I believe, all chains. Maybe I'm not right on that, but
I think you're right.
I think
Bitcoin, Cardano, Solana, Bitcoin, Cardano are ECDSA, and then the rest are EDDSA, which is right. Yeah.
Right. I think that's something, you touched on at the very beginning, but it's maybe worthwhile to circle back. Like, our entire business is around, creating decentralized custody tokens and moving assets from one chain to another, right? And creating one custody solution that can be used to move any asset from point A to point B between chains, right? That's only possible if you have an implementation that's natively like omni-chain, right? That is set up in a way that works by hitting private keys, creating private keys rather than relying on a consensus of private keys or a consensus of smart contracts on different chains, right? And I think that is the point of why we are able to create kind of a custody standard in a way that most people would have immense difficulty, because they would need to have all of these bespoke implementations literally on every single chain, and it would be different everywhere. And as you scale, the amount of complexity and things that would need to be managed would just become exponential. So I guess, why are we able to do that differently? Like, what is it in our implementation that is so fundamentally different that makes that possible?
Well, I think it's because we are using MPC to generate keys that are just that are blockchain agnostic. We're doing ECDSA and EDDSA, and wherever they're supported inside those blockchains, then we're good.
Right. Yeah. No, I think that makes sense. Maybe one other question that comes up a lot is, look, what is the future, right? So I know that we are, launching originally with 3 of 8, but then we're going to continue to scale the amount of operators, and the essentially, as I understand it, it just is increasing the threshold. It makes it exponentially more difficult for parties to collude, or at least you would need more of them, and the probability that when they colluded, they would be on the same signature, and then would not enter this identifiable aborts kind of sequence. It just becomes exponentially more challenging. So maybe just describe like that and how that all works.
Yeah, what we intend to do is we intend to increase the number of nodes and increase the threshold, and we're going to put in place this thing called a proactive security. So within a certain epoch, what we have to agree with, we're going to rotate the keys. So even if 1, 2, 3 node operators started to collude with one another, by the time they get to the threshold, the key should have rotated. So therefore, they can't actually use that key. So that's the basis of the security of the system.
Right, that makes a lot of sense. But private key.
Can I make another point? But this is going to be very difficult to do because we're using AWS Nitro. We have got the whole thing locked down.
Right.
So you shouldn't ever be able to get to the key material.
Yeah, just another layer of protection that we put in place.
Right. Yeah. On the premise of mitigating any single point of failure, is I think we've at Zenrock, in terms of the MPC, tried to build from the ground up. I really think the private key rotation aspect is probably one of the most unique things in terms of private key security, because that enables the ability for us to prevent autonomously, without us even being there, a bad actor or multiple bad actors colluding.
Yeah, and it gives us so much flexibility because we can rotate the number of parties. We can reduce them or increase them. You mean? So that's, it gives us more flexibility than you're ever going to get with a multi-sig solution.
Right.
Right. Without bad mouthing anyone, I guess my question is like, we see this term MPC used so much, right? We see people say, "Oh, our system's underpinned by MPC," like, so therefore it's secure. I think it's just really worthwhile to dive a little deeper into what differentiates our system from a lot of these more centralized MPC, where it may be a 2 of 2, where, by the way, both the nodes sit next to each other in the same warehouse in one room. You know what I mean? I think just kind of really explaining that difference between kind of your generic MPC that you'd see from, insert whatever company and what we're doing.
As far as I know, we're the only people doing this, a threshold signature scheme. I mean, that's truly multi-party computation. I mean, other people are saying they're doing this, but we all know they're really not.
Mm-hmm.
I mean, we're genuinely, as far as I know, we're genuinely the only people that are actually doing this. I mean,
yeah,
we're the only people that can do this at scale, and at a, in an enterprise setting, with all the bells and whistles that are required to give you confidence. I mean, in our solution, and we have the experience from our previous. I have the experience from my previous company of running this for years.
Mm-hmm.
You know what I mean? For like 5-6 years, and the team has the experience of running this for years. You know what I mean? So we know how to do this. We know how to do MPC at scale securely. I'm not sure anybody else can claim that.
Yeah,
I think you're right. I would also like to just understand, how long would it take a random project to do what we're doing right now?
A long time. You know what I mean? It would take man years to get to where we got to. Like, I was running with a team of 9, including myself, a team of 9, mostly PhD cryptographers for years. And even before that, the library that we're basing this on, the Milagro crypto library, has been in development for man decades. I mean, it'd be a very significant effort for anybody even to get to where we are today.
Right. Not only that from a time perspective, but also from a cost perspective. You would have to have a lot of resources at your disposal in order to actually build what we have in current day. And in the future, as we onboard more of operators, MPC operators, it's going to become even more difficult and costly.
Yeah, I agree. You mean, in terms of like actually running the system, it shouldn't be that. It's not going to be that expensive for like third parties to run an MPC.
Mm-hmm.
Right.
We're doing it. We're obviously we're engineering this out to be as light as possible on their side. I mean, you do need something. You do need. Nitro enclaves and EP2 and all. And have some skills in DevOps to be able to like bring it up. But we should make it quite easy for you to do that. We'll have run books to help you along the way.
Yeah.
Right. That makes a lot of sense. And I think, Jack, you've been quite close to a lot of our validators and operators. And from what I see from a bird's eye view, it's been quite easy from a technical perspective to actually onboard our MPC.
Yeah, I mean, these guys have, I think, to Kealan's point, right? Like, taken a lot of the complexity out of it for the validators. I mean, there's still, it's not something that you can spin up in a day as a third party, but it is something that, anyone with a reasonable level of experience setting up nodes can get up relatively quickly. So it's just a testament to kind of all of the work that's been done on our end to get us to that point. I was going to say, I think another really interesting point to bring up is like, we are focused solely on this idea of decentralized custody tokens. I think this is such a massive green grass area for us to kind of explore this idea of bringing, hundreds of different tokens to Solana and other places to really just, allow for them to access a much more liquid trading market is extremely important in crypto, because you have all sorts of wonderful, very useful, very practical assets that will, be beneficial into the future, but there's just no liquidity where they happen to be, other than potentially on centralized exchanges, right? So we are 100% focused on that, and I think the absolute biggest example that we have seen is our own Rock token, right? We're at the point where we have the Rock token on Solana, And because of that, we're able to access like a much, much larger, potential user base than we ever would have been able to just if we said, hey, you have to come to zrChain and you have to know how to do that and you have to kind of be able to deal with all the complexity associated with that. So that's our mission, right? But I think that it's really important to realize that our MPC architecture is unbelievably flexible and has the capability of doing virtually anything because at its core, all we're controlling are the private keys, right? So maybe like I think it'd be just helpful to understand from an architectural perspective how our kind of sole control of private keys, or said differently, our sole kind of use of private keys and wallets allows us to be significantly more flexible than the average product who maybe would be trying to do something similar to like DCTs.
I'm not sure I understand the question, to be honest.
So I guess the question is like, how is our architecture able to be more flexible and kind of do more types of operations than your typical your typical implementation of like the just like decentralized custody token product?
Well, I think that the key must be the fact that we are using MPC technology and we are developing. We just output signatures for ECDSA and EDDSA. So that has to be the key why we have flexibility. I mean, you just need to incorporate those signatures into whatever protocol you're using.
Yeah,
that surely is the answer.
And that's a core point. So I just think this is so important to hammer on. Like all we are doing is outputting signatures, right? We are not coming up with bespoke smart contracts everywhere. We are just controlling wallets through our MPC, and that's all we're doing.
Yeah.
So if you wanted to build an implementation that did virtually anything, it could be done using our MPC.
Yeah, exactly.
Yeah, I think that's really, when you look into the future of Zenrock 5-10 years from now, that's what's also incredibly exciting. Just the sheer flexibility of what we've built.
The flexibility of our solution too, and it is by blue sky thinking. You mean?
Yeah.
Like, we have built this from scratch. You know what I mean? We've based it upon, like I said, the Molecular Crypto C library that I've been working on with Professor Scott for a long, well over a decade. 15 years. So the whole code has no dependencies. There's no attacks from taking external code. So we could take that code and we could actually, using WASM, we could run an MPC node in the browser, for example. We have ultimate flexibility on what we're going to do in the future. Which I don't know if there's a business case for that, but it just shows the flexibility of our solution.
Well, absolutely, there's a business case for that because you're optimizing the user experience by increasing security, but also not distracting or creating a negative experience for the user while increasing security, right? So that's a huge point because usually as you increase security in the on-chain crypto world, the user experience usually gets diminished, and it's a huge hurdle for the user to operate with high security. But the whole point of Zenrock is to operate a clean UX and make it easier for the user to transact with higher security solutions.
Yeah, so that's one thing. I could see a desktop version of the MPC. There's lots of options here that we can work on in the future.
Yeah, and allowing people to build whatever products they want. That's the ultimate goal, right? It's to allow for people to build cross-chain products that rely only on the kind of the most basic building block of blockchain, the signature, and that's it. Which is really, really kind of the overall mission of everything we're doing, I think. I think it'd be interesting just to talk a little bit more about cryptography generally. Kealan, you're one of the kind of foremost experts on this topic in the entire world. Like, maybe one thing is like, what do you think people get wrong about cryptography and like their understanding of kind of this crazy world of crypto that we all engage in?
Well, I think the main problems I've seen over the years is basically implementation problems. People take papers and try and implement them, or take standards and implement them and make very silly mistakes, which lead to exploits or lead to real problems in the final solution. I mean, that's that's the kind of things that I've come up against in my career. You mean?
Yeah, it's interesting. I mean, I think there is a culture of ship, get it out, just launch it, right? In startups and the whole crypto space is startups, so it's natural to have that. But I think that's also kind of one benefit we have of having you and having Majid and having kind of a very seasoned team that really understands the life cycle of this. And isn't kind of rushing to get something out that could potentially be compromised. And that's also why we've taken longer to get to market than maybe others, right? Because we are focused on building a long-term scalable solution that is built the right way without vulnerabilities.
Exactly. We've taken a very structured engineering approach to the work. I mean, nothing gets into mainnet that hasn't been tested very thoroughly. So, like, I mean, we've never ever had in this company or in the previous company, we've never had to do like a hot fix on the system.
Right.
I mean, everything works because it is so well tested, and I think like I know me and my guys have been given the time here to do that. So I think we do take security very seriously. We do take the standard. I mean, good standard work seriously as well.
Sure. No, it's so important. Yeah, I think this was really insightful. I don't know, Adi, if you have any other questions you want to hit on.
No, Kealan, just anything else on your end that you'd like to add and take us home?
No, I think that's been really good. Hopefully, it's described the MPC solution sufficiently so people understand it. But I'm happy to answer any other questions at any time.
Yeah, absolutely. And we have our light paper out, but I think everyone could expect more detailed cryptography research from you as you get some bandwidth on your end in the future. So I know we're cranking away, but hopefully within the next 6 months or so, you'll start to see some more research reports driven by you and your team. So we're really looking forward to that. I know a lot of our partners and investors are as well. So really appreciate you coming on I guess impromptu zrTalks number 4. And then so thanks a lot, Kealan.
All right, thanks guys. See you again.
Thanks.
Bye bye.